So here we go with the group test. I do want to let you know that tomorrow for the test, you will be given this blank unit circle like you were yesterday. Now this one's already filled out because one of the groups did it. But it will be completely blank except the first quadrant will be filled in for you. So you should have all those values. You don't need to go and fill in the rest of those unless you want to. Some of you it's easier to just fill it out and then use it to reference to. But at least from there, you should be able to get what you need from whatever quadrants when you need it. Does that make sense? So tomorrow you will be given a unit circle. It's copied on your test. Okay? And the first quadrant will be filled out. Capiche? Okay. So, here we go. Solve each triangle. What does it mean to solve each triangle? Figure out all the sides and all the angles. These two questions in particular, I have to see labels. I need to see degree signs on angles. I need to see yards, miles, whatever. This one doesn't have any label on the side, so for little b right here, you're not going to have a label on the side. Tomorrow on the test, I believe it does have a label, so I'll expect to see centimeters, miles, whatever it's talking about. Okay? So, starting off with number 1, I have 2 angles, so how do I find that third angle? 180 minus 27 minus 88. What does that give me? 180 minus 27 minus 88, 65 what? 65 degrees. That should have been the easiest point possible. By the way, these two problems, we forgot to put the points on there before we printed, but these were 5 points each. Okay? So on this problem, I gave you 1 point for getting that guy, and then 2 points for each of these guys. There's the 5 points. All right, so now, I know that this is 65 degrees. So I need to find side X, which would be this guy, and I need to find Z, which would be that guy. How do I know that X is the bottom one and Z is the hypotenuse-looking one? Because it's got to be opposite the capital, right? Opposite the capital letter. So, if I wanted to find X first, I'm going to do sine of 65 degrees over what? X, the opposite side, is equal to, this is the law of sines, by the way, what should I set up as my other fraction? I need to know both the angle and the side across from it. So how about sine 27 over 10? So when I cross multiply, I have 10 times sine 65 equals x times sine 27. Should keep my degree symbols there. So how am I going to get x by itself? Divide by sine 27. Any questions on how I did that? Good answer. So let's plug this into our calculator. 10 sine 65, I'm going to hit enter, divided by sine of 27. If people miss points here, it was because of rounding. What is 19.96 round to? 20.0. Some people put 19.9. That's a problem because that 6 means that 9 can't stay a 9. It's got to move up. And if that 9's got to move up to a 10, that means that's got to move up. So I really have 20.0 what? Yards. Okay. Now let's do the other one. If I want to do Z, I'll write it up here. That would be sine of 88 over Z is equal to, and I'm going to go ahead and use the 27 over 10 again. Okay, sine 27 over 10. Why do I not want to use the sine 65 over what I just found? Because if what I just found, if x is wrong, and I use it in this process, then I'm guaranteeing this one's going to be wrong too. But if I use the original stuff, there's the potential of getting one of them right, even though the other one's wrong. So, cross multiplying again. 10 times sine 88 degrees equals z times sine 27 degrees. How do I get z by itself? Divide by what? Sine 27. By the way, your test tomorrow, we've spread it out a little bit further. Like, we've spread it over to 3 pages instead of 2. Same number of questions and everything, just to give you some more space to work. Okay? So don't freak out when you see and it looks longer. It's the same number of questions. There's just workspace. All right, so let's do this one now. 10 sine 88 divided by sine 27. 22.01. Well, what does that 1 mean about the 0? It stays a 0. So I have 22.0. What? 22.0 what? Yards. These first 2 questions probably will take you the longest time. Okay? All right. By the way, why couldn't I use Pythagorean theorem to get z? Why did I have to use law of sines again? It's not a right triangle. You can only use Pythagorean theorem on a right triangle. So, speaking of a right triangle, in number 2, I have a right triangle, don't I? So, can I use Pythagorean theorem to find little b?
Yes.
So, that would be 6 squared plus little b squared is equal to 10.6 squared. Well, I know 6 squared is 36. 10.6 squared. 10.6 squared is 112.36. Now, I don't want to round anything off here. I want to keep everything as much as I can until the very end. So let's see. B squared, how am I going to get b squared by itself? I need to do what with that 36? Subtract it. So I have 76.36. Now, how do I get b? Square root. So, I'm going to take the square root of the previous answer, and I get 8.73. What does that round off to? If I'm going to the nearest tenth, like the instructions say. 8.7. Is there a unit for it?
No.
In this one, no. On your test, there will be a unit for it. So I'm just going to write 8.7 there.
Doesn't it say to round to the nearest tenth?
It says round to the nearest tenth right there.
Oh.
Okay? All right. Angle A and B. I only need to find one of them, right? Because then the other one I can just subtract from 180 to get. So, I'm going to talk about angle A. If I look at angle A right here, I want to use not the B value that I just found because I had to round off for that. And if for some reason I got it wrong, I don't want to use it. So I want to use the 6 and the 10.6. How are they related to A? One of them is opposite. The other one is hypotenuse. So if I have SOHCAHTOA, which one am I going to use if I want to use opposite and hypotenuse? Sine. So in other words, the sine of angle A is equal to 6 over 10.6. Correct? How do I find angle A, though? You have to use the inverse sign. That's the sine -1 thing of 6 over 10.6, and that result will be angle A. So I need to go to my calculator. How do I get that inverse sine? Well, that's right above my sine button. So I have to hit second sine of 6 over 10.6. And I get 34.47. Well, that rounds off to 34 point what? 47 rounds off to 5. So I'm going to call that 34.5 what? Degrees. Once I have that, my next angle I can get by just taking 180 minus 90 degrees minus 34.5, and that should tell me my remainder. 180 minus 90 minus 34.5, and this one is 55.5. Could I use trig again? Absolutely. However, if you end up with 34.5 and 55.4, that's a problem. Why? It's not going to add up to 180. It's going to add up to 179.9, which is pretty close, but angles have to equal exactly 180, not even a tiny, tiny bit off. Okay? Questions there? We have now solved both triangles. All right. What I like about this test is most of the triangle stuff all comes first, and then we get into the unit circle stuff. So I kind of kept it separate that way. So, again, with the triangle stuff, if I'm giving you theta and we're talking about cosine and tangent, we're going to be talking about a right triangle. It doesn't matter which angle you label as theta. However, it can't be the right angle. So either of these two we can call theta. So I'm going to call this one theta. And again, with my SOHCAHTOA stuff, tangent is known as opposite over adjacent, right? So what is opposite theta? This guy? So that's 4. Adjacent theta is 3. And if I need to find cosine, what do I need for cosine? I need adjacent over what? Hypotenuse. So I know that the adjacent value of theta is what? 3. I just need to find the hypotenuse so I can put it on the bottom of that fraction. How do I find the hypotenuse? Pythagorean theorem. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. What is 9 plus 16? 25 equals c squared. So what is c? 5. So if I put that hypotenuse value on the bottom of my fraction, can that reduce? Nope. So my answer is just 3 over 5. All fractions, if they can be reduced, must be reduced. If they can be reduced, they must be reduced. Okay? Similar type problem. Here we go. Here's my triangle. Right triangle. Again, pick one of them to be theta. They're giving me cosine this time, which means they're giving me the adjacent side, which is right here. And what other side?
Opposite.
Adjacent and hypotenuse. So I've got those labeled now. In order to find tangent, I need opposite and adjacent, don't I? So how am I going to find this opposite side? Pythagorean theorem. Root 2 squared plus b squared equals 2 squared. What is the square root of 2 squared? 2. Plus b squared equals 4. Subtract 2. B squared equals 2. So what does b equal? Wouldn't it just be the square root of 2? Square root of 2. So, how do I find tangent? Tangent is opposite over what? Opposite over adjacent. Well, root 2 over root 2, what does that equal? 1. Don't write this in your answer box. I don't need to see the simplifying in your answer box. Just put the 1 in the answer box. Okay? Questions there? All right, number 5. Find the exact value. Oh, by the way, let me give you points values. These were 3 points each. This guy here is only 2 points because it's pretty easy. Tangent is what? From SOHCAHTOA, what's tangent? Opposite over adjacent. Well, if this is theta, what's opposite? 4 rad 5. What's adjacent? 8. Some people wrote that. There's a problem. You can never, ever, ever leave a fraction that's not reduced. You can reduce 4 over 8. What does that reduce to? 1 over 2. So you really have 1 rad 5 over 2. That's your answer. Rad 5 over 2. Questions there? All right. Find the sine of A if B is equal to 3, C is equal to rad 13. So let's draw our triangle. It does tell me it's a right triangle. By the way, this one is a 4-point question. Okay, so I know that this one is angle C. Does it matter which ones I label A and B? No, only matters which one I label C. So I'm going to call it A and B. They give me little b. What side is little b? Isn't it side AC? Would be that. And little c would be my hypotenuse, which is rad 13. Now to find the sine of A, sine is opposite over hypotenuse, right? Well, I don't know the opposite yet of A, but I do know the hypotenuse is rad 13. So how am I going to find that third side so I can put it in my fraction? Pythagorean theorem again. We're using that a few times, aren't we? So 3 squared plus little a squared is equal to radical 13 squared. So 9 plus a squared is equal to 13. Rad 13 squared is 13. Subtract by 9. A squared equals 4. So what does a equal? 2. So that other side is 2. So, coming over to my sine fraction, the opposite side of A is 2, and rad 13 is the hypotenuse. Now, I cannot leave an answer like that. Why? Can't have a radical in the denominator. So how do I get rid of that radical in the denominator? Multiply by rad 13 over rad 13. Now, there was one group that canceled those out and ended up with 2 over rad 13. Well, isn't that where you just are trying to leave? So let's not cancel anything out yet. I have 2 rad 13 on the top. What do I have on the bottom? 13. Can anything reduce? No. 2 and 13 can't reduce, and I can't reduce in a radical with something not in a radical. So my answer is just 2 rad 13 over 13. Questions there? Okay, now we start getting into the unit circle stuff. These two questions are both worth 2 points apiece. Now, the first one, number 7, says name 2 angles in radians. If you give me angles in degrees, I'm marking it wrong. It says it in capital letters. Give me the radian measures. So, this is the one where you're going to want to look at your unit circle. They have a sine value of negative radical 2 over 2. What do we know sine equals? Y. So I need to find 2 angles that have a y value of negative radical 2 over 2. So where am I going to be looking? I'm going to be looking at the coordinates. Where are my y values negative? What quadrants? 3 and 4. So the 2 angles I give better be in quadrants 3 and 4 in order to have a negative y value. So where are my negative y values? Well, I see one that matches right there. Do you see that one? So what's that angle in radians? 5 pi over 4. The other one that has a y value of negative radical 2 over 2 is what? 7 pi over 4. You can separate those with a comma, the word and, whatever. Questions there? Okay, if you say 225 degrees and 315 degrees, I'm marking it wrong. Make sure you give me the radian measures. All right, name 2 angles in degrees that both have a tangent that is 0. How do you get a tangent that is 0? Well, tangent is y over x, or sine over cosine. The only way that this fraction can be 0 is if y itself is 0. Doesn't matter what x is for the time being. It only matters that y has to equal 0. Whenever you're talking about a 0 as a coordinate, you're talking about one of your quadrant angles. Those are the only ones that have 0s and 1s in them. So, which ones have a y value of 0? that one does. I could call that 0 degrees. Or I could call it 360 degrees. Either way. Where's the other one that has a y value of 0? 180. So I'm going to put 0 degrees and 180 degrees. Or you could put 180 and 360. I don't particularly want 0 and 360 because technically that's the same angle. Right? Just the rotation issue. So try and give me 2 of those. But 360 is also an acceptable one there. Questions there? No? All right, so those were 2 points apiece. The front side total was 26 points. Back side. You ready? These ones were 3 points apiece. These guys were 4 points apiece for a total of 24 on the back side. That's where our 50 points comes from. All right, draw an angle with the given measure in standard position. Standard position means what? Our first side is on the, or our initial side is on the x-axis, and then that terminal side is going to be in one of the 4 quadrants, or potentially on a quadrant also. Now, negative 230 degrees. Negative means I'm going to start what? Going up or going down? Going down. I know that going down from here to here is 180, correct? If I were to go all the way to this, I would be at negative 270. So 230 is somewhere in here. It's in quadrant 2. So, something I had to take points off a lot for yesterday. People did not put their arrow. That seems like a minor thing, but that's kind of important because it distinguishes a positive from a negative angle. So put the little arrow there. The other thing I specified to the class, and almost nobody did it, was you have to give me one of those measurements so that I know how far into that quadrant it is. So if I'm looking here, this was 180. If this is 230, what is this angle right here? 50 degrees. Label it. That's all I need. But I need it. Is that one my reference angle? Or is this guy my reference angle? The 50 is my reference angle. Why? Because it's going to the x-axis. The other one goes to the y-axis. It's not my reference angle. So I can just go ahead and write 50 degrees right there, and I'm good to go. So important points. We've got our initial side on the positive x-axis. We have our arrow, and we have that 50-degree reference angle. Okay? Capiche? All right. Now let's look at this guy. 680 degrees. We have a positive angle this time, so let me think about this. If I start here and I go 1 full revolution, that's 360 degrees. Yes? Now I'm going to start going, let's see, 360. Whoops. If I go another half circle, that would be another 180 degrees. That's still not far enough, is it? So I know it's going to be more than that. Yes? If I add another 90 degrees, let's see, 630, it's going to be past that still, isn't it? So I just kind of go quadrant by quadrant to see where I'm at. Is it going to be a full another 90 degrees? No, because 630 to 680, it's going to stop somewhere in there. I need to put my arrow. So if this is 630 and this is 680, this is 720, isn't it? What is this angle right here? 40 degrees. Is that my reference angle? So I'm going to put that right here. Could I have labeled this angle instead? Sure, you can label this angle if you want to, but your reference angle is still 40 degrees. But one of those two has to be labeled. Capiche? All right. These two, if you remember our patterns, you can tell the reference angle just from looking at the fraction. Because if the fraction has a denominator of 4, what's the reference angle? Pi over 4. Don't tell me 45 degrees. This problem is not a degrees problem. It's a radians problem. This one right here, if the denominator is 3, what's the reference angle? Pi over 3. Okay? Now, in my head, I know that 45 degrees is pi over 4. So I need to go 45 degrees 15 times in the negative direction. Does that make sense? So if I remember correctly, that would be, well, I can look here on my graph if I want to. If I start here, that would be 1, 2, 3, 4, 5, 6, 7, 8. It's more than one full revolution, so I'm going to go ahead and draw that in the negative direction. That was 8, 9, 10, 11, 12, 13, 14, 15. I'm ending up in the first quadrant. So let's see, I'm going to end up there, but I have to keep going around until I get there. There we go. That's what my arrow looks like. Since I've already identified the pi over 4, just label your reference angle and you're good. You're done. Okay. 5 pi over 3. Well, pi over 3 is 60 degrees, so there's one, if I count by the pi over 3's. I think, actually, 5 pi over 3, yep, it's actually a value on my unit circle. So what quadrant is that terminal side in? Fourth quadrant. Doesn't make a full revolution, it just starts here and goes, boop, right there. You know what I'm forgetting to draw in here? My initial side. Shame on Franken. Let's go draw that initial side there. There we go. Now I feel better. And I already identified the reference angle, so let's go ahead and fill out the reference angle. If you just label it right there as pi over 3, you're done. Any questions about those 4? There's a lot of little things that I'm looking for. That stupid little arrow I'm looking for, because it does have meaning. That reference angle, if you label the reference angle, that's the easiest way to do it, because you have to list the reference angle anyways. And if it's in degrees, stick with degrees. If it's in radians, stick with radians. Yes, sir?
How do you find the reference angle from number 10?
Number 10, because I knew that I had gone 680 degrees. 680 degrees. And I know that 2 full revolutions is 360 plus 360, which is 720 degrees. So I just basically counted from 680 to 720 is 40 degrees. Okay? All right, last 3 problems. State the reference angle and find the exact value of the trigonometric function. Well, I love reference angles when we're talking about radians because those ones are easy. So number 13, what's my reference angle? It's in radians, denominator's 3, reference angle is pi over 3. What are my 2 things about reference angles again? They're always acute and they're always positive. Even if the angle itself is not positive, this one is, but if it's not positive, the reference angle still is positive. So, here's what I'm going to think of. The sine of theta is really the y-coordinate at that location, correct? And if I'm asking you about sine, cosine, or tangent, these will be values on the unit circle. So I just need to figure out what is this reference angle, and then identify if that particular value is positive or negative in that quadrant. So I'm in quadrant 4. Is the sine value positive or negative in quadrant 4? Remember our all students take calculus? Well, in quadrant 4, cosine is the only thing that's positive, so my sine value is going to be negative. As soon as I know whether it's positive or negative, I just look at the reference angle, which is pi over 3. Pi over 3. The sine value is radical 3 over 2. So I have negative radical 3 over 2. Easy enough? Okay. All right. This one right here, negative 1020. All right, we're going to have to do a little thinking for a reference angle. So I'm going to follow this. I know that this revolution is 360. Another full revolution is 720. I'm going to start writing them. What is 720 plus 180? Sorry, 720 plus 180. Type that in backwards. So this, by the time I get here, is negative 900 degrees. Do you get that? Okay. So this would be negative 990, right? If I add another 90 degrees to that. So if this is negative 1020, what is this angle right here? Well, how do I get from 990 to 1020? This is 30 degrees, isn't it? Questions there? You get how I did that? Is that my reference angle? My reference angle is actually this guy, which is what? 60 degrees. So, my reference angle is 60 degrees. Since my terminal side is in that first quadrant, will the cosine be positive or negative? Positive, because all the functions are positive in first quadrant. So I just need to go to my reference angle and pull out the cosine value. So 60 degrees, what's the cosine value? Cosine is x, so we have 1/2. So? Last question. 270 degrees. What's the reference angle? 90 degrees. I'll give you a hint. If your terminal side is here or here, anywhere on the y-axis, your reference angle is 90 degrees. If your terminal side is here or here on your x-axis, guess what your reference angle is? 0 degrees. Okay? So, tangent, I know, is sine over cosine, or y over x. So I'm going to go to 90 degrees. Actually, let me step back for a minute. Is tangent going to be positive or negative? Kind of tricky because it's not in a quadrant, so that was kind of a mean question. Since 270 is a value directly on my unit circle, I'm going to use the values at 270. So when I look at the y value at 270, what is the y value at 270? Negative 1. What is the x value at 270? 0. Anything over 0 is what? So I just write undefined. Any questions about those guys? All right. Again, it is going to be 3 pages long tomorrow, but it is no more questions than this. It's just extra room to write. The back side of the 3rd page will have that unit circle, the blank one with the first quadrant filled out for you. Okay? All right. Happy studying.